Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will read about the velocity and acceleration of a fluid particle in 3-dimensional. Okay, and it is part of the kinematics of fluid flow. So we will study about the resultant velocity and components of velocity, local and convective accelerations, and acceleration in 3 directions. Okay, so total acceleration. So what is the velocity? Velocity at any point, suppose this is x direction, this is y direction, this is z direction. So if particle is here, then its velocity, resultant velocity, can be denoted as v, which is equal to ui plus vj plus zk in vector form. Okay, and this u, v and z can be function of four things. U is equal to function of xyz coordinates, means space and time. Okay, similarly this is f1. V is equal to f2 x y z and t, all are the function of space and time. F3 is equal to V3 is equal to F3 x y z and t. Okay, so V is equal to resultant velocity, which is this, and if its scalar value can be found by resultant scalar value can be found by this formula, u square plus v square plus, sorry, this is w square. Okay, so u is the velocity in this direction, v is velocity in this direction, and w is velocity in this direction. So if we apply chain rule, then we can find total acceleration ax is equal to, from this, in x direction ax is equal to du by dt. Okay, differential of velocity is acceleration, so it can be written as del u by del x into dx by dt plus del u by del y into du by dt plus del u by del z into du by dz, del u by del x into dx by dt, del u by del y into dy by dt plus del u by del z into dz by dt plus del u by del t. So this is chain rule. Okay, so from here you know that dx by dt is u, dy by dt is v, and dz by dt is w. So it can be rewritten as u del u by del x plus v del u by del y plus w del u by del z plus del u by del t. So this is acceleration in x direction. Okay, so x is this. Similarly ay can be written as v, this is u, v del v by del x plus v del v upon del y plus this is u del v by del x plus v del v by del y plus w del v by del z. Okay, plus del v by del t. This is our a y. Similarly in z direction it can be written as u del w by del x plus v del w upon del y plus w del w upon del z plus del w upon del t. Okay, this is our az acceleration in z direction. So this is our acceleration, and this is total acceleration. And from here, if it is steady flow, then del u by del t, del v by del t, and these terms will become 0 for a steady flow. Okay, so for a steady flow it will become simple, and it will become ax is equal to del u by del x plus u del u by del x plus v del u by del y plus w del u by del z. Ay will be equal to u del v by del x plus v del v by del y plus w del v by del z. Similarly, acceleration in z direction will become u del w by del x plus v del w upon del y plus w del w upon del z. Okay, so this is acceleration in z direction. Okay, so resultant direction acceleration will be axi plus ayz j plus azk. Okay, and scalar value will become resultant ax square plus ay square plus az square. Now what is the local convective acceleration? So local acceleration is the rate of change of velocity with respect to time. So in this part, if you see this acceleration, so this del u by del t, del v by del t, del w by del t, this is called local acceleration. Okay, this is due to change with respect to time, and this is a spatial change, like this part, it is called the convective acceleration. Okay, this is due to change in space. So I hope you understood what is the velocity and acceleration in 3 dimension. Okay, so if you have any doubt, you can ask in the comment section, and in our next video we will solve some numerical problem based on these equations. So thank you for watching.